Okay, so I don't know if I'm going to do this justice, but I'm going to give it a shot. So the way that I understood it was that last question was set up off of the first question. So, pardon me, it looks like the slide that says infusion. So he gave us a whole bunch of information right here at the beginning. So we have available 100 units of heparin per 1 milliliter. The ordered dose is going to be 17 units per kilogram per hour. So we need to know, oh, and the patient is 65 kilograms, 65 kg. So the way I like to set up all my questions is by going over and saying, hey, this is what's available, this is the order, and we need to know how many milliliters per hour. That's what's being asked. So we have ml per HR, because we don't know that. So we know this one right here is going to be the X whatever. So that's how we're starting that equation. So we've got X ml. When it's per hour in a fraction, you're going to do HR equals. So now that we have this all set up, where do we find milliliters in our information given? The only place we see that is right here in what we have available. So we have 1 ml over 100 units. All right, so next thing here, I like to treat the times sign as a little arrow. So units are going to be going right up here. So the only place that we find units in the information given is right here. So that's going to be 17 units over, oh shit, kilograms per hour. And we just write that out as kg per HR. Now we need to try to go ahead and knock out this kilograms, because we want to find out the hours. So we need to leave that one there. So we're doing another times right there. Again, this is acting as an arrow. That kilograms is right there. So we need to get that kilograms up on top. The information that we have is right here. So we have 65 kg. Nothing spectacular about that one. A whole number that goes into a fraction is going over 1. So now we're going to go ahead and knock out all these units that we don't need, or all these labels. So we can get units out of there, units out of there. We can get kilograms out of there, right there, equals. So now we have one label up top. That's going to be your milliliters. We've got one label on the bottom. That's going to be hours. So we're going to go ahead and multiply 1 by 17 by 65. Let me pull up my calculator here. What's 17 times 65?
The answer is 1,105.
105 over. So now we're going to do 100 times 1 times 1. That's going to be 100. Carrying our labels over, ml, and this is HR. So 1,105 divided by 100 is going to end up being That's going to be 11.05. We need to round to the nearest whole number. That's going to be 11 mLs. So we can go ahead and get rid of this. That's going to be 11 ml per hour. So this is our base for our infusion. Now, the next question is about the bolus, as well as I guess let's go ahead and just do the bolus now. So their numbers came back low, so we need to give them an increase. We're increasing that and just doing a bolus of 3 units per kilogram. So we need to know how many milliliters we're going to be giving in this one. I don't have the slide number on me, so I apologize. But what we're going to end up doing is just XML. So this is kind of going back to what we were doing before. Now the information that we have on this slide is a picture of heparin, 1,000 units per 1 milligram. And we also know the patient's weight is 65 kilograms. So what do we know? We know that the patient's weight is 65 kg. We know that we have available 1,000 units per ml. And the order is to give 3 units per kilogram. So again, we're always setting all this stuff up so we have a reference. But what we're going to go ahead and do, since we have the milliliters right here, we're going to find where we have the milliliters up here at the very top, and that's right there. We have 1 ml over 1,000 units. Okay. Times, again, use this guy kind of like an arrow. So we need to get units up top. So bingo, we got 3 units per kilogram, but we don't need to know the kilograms at the end, so we need to go ahead and get rid of that. It's just going to confuse the heck out of us. So kilograms is going to be going right up there. Where else do we find that? Right here in the patient's weight. 65 kg over 1. Son of a equals. Alright, so let's go ahead and get rid of the units that we don't need. So we don't need the units right here. We don't need the units right here. We got 1 kilogram. We're going to go ahead and get rid of that kilogram. So we need to multiply. This is going to end up being ml. Let's go ahead and get that out there. And then this is just going to be a whole number. So 3 times 65.
It's 195.
195 over 1,000 divided by 1,000.
That would be 0.195.
Equals 0.195 ml. Well, we need to go ahead and round this one because the dosage, we want to get it to an even number if we can, especially when it's something so close. So we're going to round this number to 0.2 ml. That's going to be our bolus, our additional bolus. Okay. If you have any questions at this point, just holler at me. Now, we need to increase the rate by 3 units per kilogram per hour. So we're increasing 3 units per kilogram per hour. Now you're probably, my big thing was I didn't know where the heck what we were increasing. It's just from the previous question. So we have the original 17 units per kilogram per hour. That's the order. So we need to do 20 units per kilogram per hour. That's now what we need to find in that information. So let's see here. So the question is asking, what is the new milliliters per hour? So ml per HR. That's how we're going to end up setting up our question here. XML over HR. Let's go ahead and get the rest of our information in here now. So again, we know that the patient's weight is 65 kilograms. This is our order, and available on that slide we have 100 units per ml. So we got 100 U per ml. So we are gonna go ahead and start working on this equation now. So with the the way that you're setting this up, you have the milliliters up top. You want to get that directly on the other side of that equal sign. Well, when you take a look at the information that you have right up here, the ml and the units is where we find the ml. So we're going to do 1 ml over 100 units. Now we're going to do that handy little thing that we do with our X and just make it a little arrow. Excuse me. Where are we finding units at besides this guy? We find that right up here in our new order of 20 units per kilogram per hour. So we're doing 20 U over 1 kg per hour. We want to figure out milliliters per hour, so we're going to keep this one right here, and we're going to keep this one right here, which means we need to get rid of the kilograms. Times, make it a little arrow. Again, we know that the patient's weight is 65 kilograms over 1 equals. So let's go ahead and get rid of all of our units, or our labels that we don't need. So we've got the units down here and the units up there. Got the kilograms down here and the kilograms up here. And now we can go ahead and multiply. So what's 20 times 65?
The answer is 1,300.
1300. Now we need to go ahead and carry over our label here. Over. We've got 100 times 1 times 1 equals 100. 100 what? We've got our label right here, hour. So 1,300 divided by 1,000, son of a bitch, equals 13 milliliters. That's right there, per hour. Right there. Hope that helps. Holler if you have any more questions, comments, or concerns.